Alrighty, welcome to chapter 4. It's already to chapter 4. That's kind of crazy, but we are going to get this party started. So we're going to start here with what is the terminal side. So the terminal side is going to be where it ends. So basically when it has the same ending, you want to be in between 0 and 360 degrees when we talk about a terminal side. So 2,759 is a little bit outside of our purview. So what I'm going to do first is I'm going to say 279 divided by 360 and see what number I get. So I get approximately 7. It's 7 and some change. Okay? So what that means is that I know that if I take 279 and I subtract 360 for how many times degrees in a circle, it's going to go around 7 times. And what I'm going to be left with is going to be my terminal side. So when I go ahead and I do that, I get 239 degrees. Alrighty, so that is our terminal side, and it says in what quadrant is that in? Well, if I go ahead and start this off, it is 0, 90, 180, 270. So it's going to be somewhere in here at 239. So my answer to number 17 is going to be quadrant 3. Alrighty, so reference angle, remember, is going to be the angle and the x-axis. So you're going to find your terminal side. So I should say terminal and your x-axis. So it's basically the kind of the exact same thing. All right, we have 216 degrees. So 216 degrees divided by 360. Should have had that number ready. So ladies and gentlemen, I apologize. Let me get my calculator out here. So 2016 divided by 360, we're going to get 5.6. So we're going to say approximately 5. Okay, we'll just say approximate. So we'll do 216 minus 5 times 360, and that's going to land me with 216 degrees. So doing the same sort of thing we did before with our quadrant plane. Okay, so this is 180 degrees, so 216 would be right there. So my reference angle is in between my terminal side, which is here, and my x-axis right there. So this is going to be my theta, that reference angle that we need. So we'll do 216 minus 180 degrees, and that's going to give me 36 degrees, and the answer for number 18. Alrighty. So ladies and gents, moving on to number 19. It says, what is the angle this coterminal? So where does it end? Once again, we want it between 0 and 2 pi. But since we're in radians, we're going to go ahead and do that same sort of idea. So I'm going to do 335 divided by 4. And that's going to go ahead and give me approximately 8 and 3/4 pi. So because I know that 8 is basically meaning that it's going to go around 4 times because it's 2 pi. I made a 0 there, so it's 2 pi is all the way around. So 1, 2, 3, 4. That would be my 8 pi. What I'm left with is this 3/4 pi. And that's actually my coterminal. So we could say, alrighty. So that's right here. Get a different color. So that's my 3/4 pi. We would accept 135 degrees, or again, 3/4 pi. I would leave it in 3/4 pi since that's the one that was given. They gave you in terms of radians. So generally you want to leave it that way. Alrighty. So number 20, we are all about the sine. So sine is going to be opposite over hypo, and that is √5 over 3. Cool. And then we're looking for cosecant. Cosecant is the same as 1 over cosine, or we could say it's hypo over opposite. So when we switch this, because our opposite is √5, so we'll go ahead and put a √5 down here, and my hypo is a 3, this is a great start, but we can't have a radical in our denominator, so we're going to rationalize. So whatever this bottom number is, we'll go ahead and multiply the top and the bottom by that √5, and I'm going to get 3√5 divided by 5, and that's going to be our answer for number 20. Alrighty, so So the sine is equal to, that's supposed to be an equals, I'm pretty sure, a negative 2 7. So once again, sine is going to be negative 2 divided by 7. And theta is in quadrant 4. So what that means is I'm going to be down here. What I really need to look at here before I start is all students take calculus or all smart trig class. Either way. But either way, we look down here in this fourth quadrant, which is what we're asking to use. Only the cosine is negative, so I know that this tangent, whenever I get there, is going to be a negative value. Okay, so now I'm going to erase this for space. And so I'm going to draw it as if it was in that quadrant, where I'm going to go ahead and go 7 and then negative 2. Because you always start at your origin. So when we need tangent, remember tangent, if I erase this to give myself some room, is opposite over adjacent. So we already have the opposite side, but I am missing that adjacent. So I'm going to call that x for the time being. And we have a lovely right triangle here. So that's a squared plus b squared is equal to c squared, where our c is always the hypotenuse. So x squared plus a negative 2 squared is equal to 7 squared. So x squared is going to be 49 minus 4. So x squared is going to be 45. So we'll say x is the same thing as 3 root 5. That's after you went ahead and took the square root of both sides there and then did a factor tree. So now that I know that this is going to be 3 root 5, let's write this as a negative, because I know it has to be negative because it's in that quadrant. And then the opposite is 2 over 3 root 5. So once again, we can't have a radical in the denominator, but the issue is not the 3 root 5. It is just the good old root 5 there. So I'm going to multiply just the top and the bottom by that root 5. And I'm going to get negative 2 root 5 over 15. Because these two right here would give me 25. The square root of 25 is 5. 3 times 5, 15. So that is our answer there for lovely, lovely number 21. Moving over here to 22. So we're going to go ahead and says the right angle is tangent. Now this is positive, so I'm going to go ahead and assume that we're going to be in that all positive region of quadrant 1. So I'll draw my triangle. Here's my theta, and tangent is opposite over adjacent. That comes from our SOHCAHTOA. So that's 6 over 11, and cosine is going to be adjacent over hypo. So I need to find what that side is right there. So once again, we'll use Pythag. So 6 squared plus 11 squared is equal to x squared. So 36 plus 121 is going to be 157. And then we'll take the square root of 157, and that's going to be x. And that really doesn't break down, so we're just going to call that the square root of 157. Alrighty, so adjacent, that would be this side right here. We'll do that in a different color that we can see a little bit better. Hypo is going to be our longest side here, opposite your 90-degree box. So this is going to be 11 over the square root of 157. And hopefully you've noticed a trend where you can't have a square root in your denominator. So that's going to give us 11 root 157 over 157. And that is going to be our answer for this bad boy right here. Let's bring back the rainbow pen. That's fun. Alrighty. So, ladies and gentlemen, when we get to this next section, it talks about angle of elevation. The best thing you can do is draw a picture. Angle of elevation is always up like this. Depression, just for funsies, is always that one. But that's not what we have for this example. So I'm going to erase my theta because I have a degree to put in there. It says it's 41.5. Your theta always goes in that corner right there. The height of the building is going to be 144, so I'm going to put the 144 right there. And then I'm going to look for the base. So whenever looking for the base, that's always going to be down here. So what we have, ladies and gentlemen, is I have two sides that I have any information about or I care about, which is the opposite or adjacent. Don't try to bring in the hypo. It's not going to help us in any case right here. So if I look at my SOHCAHTOA, opposite and adjacent means that we should definitely use tangent. So we're going to go tangent of 41.5 is equal to opposite over x. So one thing I will mention right now is that because we are dealing with degrees, make sure you go to your mode on your calculator, go down to either radian or degrees and switch that over to degrees. That's going to make your life a lot easier. So we'll leave that over there in a second. So I'm going to multiply both sides by x to get rid of that fraction because no one likes that. So I get x times the tangent of 41.5 is equal to 144. Then this tangent right here is a ratio. It's a number. So we can divide both sides and make my life a little bit easier. So we'll divide both sides by tan 41.5. Tan 41.5. And then we can put that into the calculator just as is. So I'll just show you really quickly. You do get a calculator on your final, so we might as well show you how to use it from time to time. So just make sure when you do your tangent of 41.5 that you go ahead and you close those parentheses. It's going to make your life a lot easier if you have multiple trig functions going on. So that's going to be 162 and essentially 0.8. So does it clarify and tell us what to round to? No, so we might as well just call that good. Alrighty, on our next one here, I'm going to erase this so we can focus. It says a kite is 104 above the ground, so I'm going to assume that it's going to look like this. And we're going to say that 104. I was looking to see if it said angle of elevation. It does not. It says that the string is 365 feet. So this is you right here. This is your kite. Obviously, this has to be our string for it to work. Okay. So I have a lovely 90-degree box because we talk about height is straight up and down. And what angle does it make in respect to the ground? So that's going to be that angle right there. So I have an opposite. I have a hypo. And using the same SOHCAHTOA we've been for, we want to use our sine. So I'm going to go sine of some theta we don't know yet is equal to 104 over 365. Then because we're looking for a theta, we're going to use our inverse trig functions. So when we plug that in the calculator, make sure you hit the second, then the sine button of 104 divided by 365. 365, closing my parentheses. So we get 16.5 degrees. Called the same rounding stuff that we did before. Alrighty. So, ladies and gents, in our next one, again, always key on for words like angle of elevation. That's going to help you out. So for angle of elevation, I'm going to draw this triangle right here, make this 11.4 because that's always our theta. Right angle right here. It says the distance to the base of a tower. Anytime you see base, think of along the ground. So this is going to be 925. And then we're looking for what is the height of the tower. So this is an x. So it looks like here we're going to use tangent because I have opposite and adjacent. So tan 11.4 is equal to x over 925. And this is going to be a lot easier than the previous one because we just have to multiply both sides by 925. And so we're going to go ahead and get 106.513. So a couple of things. As I look at this example and just any example going forward, does your answer make sense? Let's go back to geometry. This angle is 11.4, which means this is going to be 88.6. So if this is a smaller angle, it's going to go to a smaller side. This right here is a bigger angle. It went to a bigger side. So our answer does make sense, even though it's a lot smaller than the other one. You can use that to really, really help yourself out. Okay, so an example, let's go back to that other one. I erased it, never mind. So just a heads up. So moving on to 26, before we tackle 26 here, I just want to say it's just because we give you this as a cofunction, make sure you know all your cofunction rules. It's not just, hey, I need to know this exactly one and they're going to change the number. It's probably going to be something like a sine or a secant or a tangent or something like that. All right. So, ladies and gentlemen, our cofunctions is, let's go with cosine since that's what we have. Cosine of whatever your theta is going to be equal to the sine of 90 minus that theta. So we'll go ahead and plug in our 81. So this is going to be 90 minus 81. So our answer is just going to be the sine of 9 degrees. That's always fun when it's nice and easy. All right. So, ladies and gentlemen, our next one here, we're looking for the sine again. I'm going to do this really quickly to know where I should land. So, if I go ahead and say, all students take calculus or a smart trig class, my tangent is negative. So that means I'm either here or here. Okay. Then it says my tangent is positive. So, sorry, my cosine, is positive because it's greater than 0. So that means that I have to be down here in that quadrant where my tangent is negative and my cosine is positive, meaning that down in that quadrant, my answer better be negative for that sign. All right, so I'm going to draw my triangle accordingly as if it were in that. So it's going to be opposite. Did I just make this up? Is it really positive? And yep, sorry guys. So it says equals, so let me back up. Sorry if it's having issues. Let's try that again. So all students take calculus. So I need positive and positive. So that means it's going to be in this region right here. Okay, because that's the only time both of those are going to be positive. So good thing I didn't get too far into this, but I'm going to draw it as if it's in that first quadrant. So this is going to be opposite over adjacent. So the opposite's here, the adjacent's here. This is your hypo. So we're obviously going to need the hypo at some point because we are dealing with cosine, and cosine is going to be adjacent over hypo. Excuse me. We have the sine, which is now going to be positive because we're in that first quadrant, and then this is going to be opposite over hypo. Sorry guys if I have confused you with this example. We're just going to keep on rolling though. So Pythagorean theorem, 3 squared plus 5 squared is equal to x squared. So 9 plus 25 is going to be root 34. And this breaks down, but it's 2 and 17. And since those aren't pairs, we're just going to leave it as that. So from my theta, farthest away is the opposite. The longest side is the hypo, and what's left is the adjacent. So it's opposite 5 over hypo root 34. We'll rationalize, so root 34, and this is going to go ahead and give us 5 root 34 over 34. And that's our answer here for 27. Making sure I did this one right. I apologize for that. All right, so this is where we got into the more of the graphing part, so the phase shift. So the first thing we always should be doing is looking inside that parentheses and noticing that that is not factored. So we need to factor out so it's just x, because we want just x in your parentheses. So I'm going to divide everything by 3. So 3 goes into this 3 over here to make it just a 1x. And then 3 goes into pi over 5. Well, it doesn't go in evenly, so let me erase this to show you. So divide that by 3. So anytime you have to divide, we're going to make it, and then that's 3 over 1, so we're going to flip it. And so this is going to become minus pi over 15. Alrighty, so ladies and gents, what is the phase shift? The phase shift is what is the shift inside here, our side to side. So I'm going to set that equal to 0. So x over pi over 15 is equal to 0. So our phase shift is going to be pi over 15. So make sure you factor that first. Alrighty, moving on to this next one. What is the period? So that's our b value that we're looking for, but once again, this is not factored. So I'm going to go ahead and divide everything by 5. It's whatever, ladies and gentlemen, is in front of your x, or in this case your t, whatever that leading coefficient is in that parentheses, that's what you're going to divide by. So in the previous example, it was a 3 that was in front, and this is a 5. And again, the previous example, it was a x, and in this one, it is a t. So regardless of your variable, whatever the leading coefficient is, that's what you're going to take out. So 5 goes into 5 to make 1t, and then 5 goes into this. We'll do this again. 5 pi divided by, pi divided by 3, divided by pi, divided by 5, excuse me. So that's over 1. So this is really going to turn into pi over 3 times 1 over 5. So this is going to be plus pi over 15. All right, I'm going to erase this to finish writing my equation. So I factored out the 5, and then we have a -9 cosine. So our period is always in reference to our b value. So our period is equal to 2 pi divided by b. So this is going to be 2 pi divided by that 5. Again, it's this value right here, always. And since it doesn't reduce, that's your answer, 2 pi over 5. Cool. Alrighty. So, ladies and gentlemen, boys and girls, we have what is the positive asymptote, the smallest positive asymptote for this. So I'm going to go ahead and say, all right, this is secant. So it's just like cosine, and that's where I'm going to start. So I'm going to graph this, and there's no other shift. So 1, 2, 3, 4. This is my 2 pi. This is my pi. And obviously this is being 0. So remember, secant is related to cosine. And so it's basically 1 over cosine. So I'll start at 1, down to -1, back up. So that's the cosine graph. Cool? Now, what we really want are those dots, because anytime it hits, in this case, our midline, I'll just say ML, that's going to be our asymptote. So those are our 2 asymptotes. And so this would be going up like this, down like that. And since it wants the smallest positive, that's going to go ahead and be this one here we'll do in red. So what is that value? So this is going to be pi over 2. Because if this is pi, that's going to be half of that, which is pi over 2. That's the smallest asymptote. Okay? All right. So to 31. All right, it says, what's the exact value of cosine? I'm going to do this over here so I have some. So I have cosine -1 of -1/2. Okay, so let's flip that. So a cosine of some theta, which is what we're trying to find out, is going to be a -1/2. Alrighty, so ladies and gentlemen, what is the exact value for what we're looking for here? So we're going to say all students take calculus. So because we are in our principal values here, because we're talking about inverses, those are our principal values. So this is going to be my quadrant that we're going to be in, because that's where my cosine is going to be negative. So we set this up. Erase this and bring this right underneath it. It's going to be in this quadrant. And again, we're looking for whatever that theta is, where this is the opposite and this is the hypo. But really we know that this is going to be just means 1/2. Sorry, this is the adjacent. I was like, I knew I was writing that wrong. This is the adjacent, so that's 1/2. That's negative. This is my hypo. So that means this has to be the √3/2. And I love my visuals, And so I go, okay, what is opposite the root 3 over 2? That means this is always the 60 degrees. So how do we get from here? That is going to be 120 degrees, or 2 pi over 3. And we'll accept either one of those as far as our value for that. Cool? Alrighty. So it says draw the graph. Let me draw this in. For -3 cosine of x, then do our domain and range. So first thing I'm going to do is I'm going to look for my midline, which is right here. And because it has nothing, we're going to assume our midline here is right here at 0. Next thing I'm going to look for is my phase shift, which is inside my parentheses. It's got none, so that's good. It means it's going to start right on my y-axis here. And then we're going to say, okay, this is a -3. So this is my amplitude. So it will start on either a max or a min, but because it's negative, we're going to start on a min. So I'm going to put my min right there. And then I'm going to go and do my critical points. Alrighty. So my graph is a little bit funky here, so I'm going to go ahead and say, wait a minute, we got to make sure we're doing the full cycle here. There we go. Went too short there with pi over 4. So there, right there is my cycle. Cool. So domain, it's going to go and be an oscillating curve forever. So that's from -infinity to infinity. Now my range is going to be our min and our max here. So my range is going to go from -3 to 3. And since it includes both of those values, it gets brackets. Cool. Alrighty, moving on to the next part here. Well, looks like it didn't copy over here, so I'm going to hit pause and upload it, and I'll be right back. Oh, sorry, flipped it around here. Here is the second part of the review. I'm hopefully making sure that you have this now. If you don't, we'll go ahead and fix that. But here's the last part of what we need to be doing. And so, ladies and gentlemen, we'll talk about angular speed. Angular speed, which we've talked about that as our lowercase omega, is going to be distance around time, but the distance is really theta. So it's theta around time. So this is going to be the formula that we're going to be using. And what needs to be happening is that this needs to be in radians. We'll say rads, and then this is whatever time that they're going to go ahead and give you. So in this case, we're going to say it's radians per minute. All right. So regardless of, ladies and gentlemen, where you are when it comes to angular speed, all you're going to do is take your revolutions and convert that to radians. So let's use our chemistry for a second. So in chemistry, we would say, some of you are like, no! So 2.2 revolutions per 1 minute, and I want it to be minutes, so this minute's not going to change, but the revolutions is. So I know in 1 revolution, there's 2 pi radians. And then you just multiply across, so this is going to give me 4.5 pi for my radians per minute. And that's going to be what we're going to put in for our theta. So in this case, it's going to be 4.5 pi per minute, and then obviously 1 because it's 1 minute. So we're going to say it's 4.5 pi, and then this is going to be feet per minute. Okay? Since that was, and so now when we talk about linear speed is when it matters what your radius is. So this is going to be, our speed is going to be your radius times, I should say, not our theta, but really our omega. So for Cooper is the one that's cautious. So his linear speed, his radius was only 7. So he's going to go ahead and be going a little bit slower than Mihalis. Mihalis is going to go ahead and be the daredevil here, and he's going to go 18.5. So to cover the same ground in the circle, Mihalis has got a lot more place to go, or a lot more distance to travel. So that's why Mihalis is going to be going a lot faster. So let's do our Cooper here. So S is equal to R omega. So our radius is 7. and then 4.5 pi. And then we just throw that in the calculator. As a word to the wise, whenever you're taking a standardized test or final, I understand that you have a pi button right here, but you really want to just do 7 times 7 times, times 4.5, and then times pi, which is 3.14. Because I know that that is not the most precise answer, but that's going to be the answer they're looking for. So in this case, it's 9891. 9891, and that's obviously going to be feet per minute. Alrighty, let's find Mihalis. So in this case, it's going to be 18.5, and then 4.5 pi, and then when we plug that into a calculator, we're going to get 261.54. Gravy? Alrighty, ladies and gentlemen, boys and girls, let's write some equations, and then we'll do some domain and ranges, and then we're going to call it good. So our sine equation, okay, it's got a period of 6, so let's go ahead and take a look at that first. So I'm going to go ahead and say, remember, period is 2 pi for sine divided by b. So 6 pi is equal to 2 pi divided by b. So I'm going to go ahead and multiply both sides by b. Cancel there. So I get 6 pi times b is equal to 2 pi. Divide both sides by 6 pi. And then reduce. And so our b is going to be 1/3. It's not even 1/3 pi. It's just straight up 1/3. Okay? So, ladies and gentlemen, boys and girls. Hey, ladies and gents, I apologize. I just wanted to make sure that I had done my math right. It sounded a little funky, but we're good, so we're going to move on. All right, so I know that this is going to be 1/3 b. There's no phase shift. I don't see any phase shift. So I know that this is going to be sine of 1/3 x. But what I'm missing is going to be the number that's going to go in front for my amplitude and what's going to go here for my range. So I'm going to erase this to give me some space here and find that. So the first thing you want to do to find your midline is you're going to be doing your average. So -4 plus 11 divided by 2 is going to be 7/2 or 3.5. It's really up to you. And since it's positive, we'll say plus 3.5. Alrighty. So how are we going to go ahead and get there based on what our minus is? So if my midline here is at 3.5 and my least number, or the min, is going to be -4. So how did we go down to get there? And so we went down minus 7.5. And to go up, because our max here is 11. So if I put 11 up here, how do I get up to that point? That's going to be positive 7.5. So that's where the 7.5 comes up here. And then we're going to put a plus or minus because we don't know where it's starting. So it could start and go up, or it could start, well, actually, let me take that back. We know where it's starting. We don't know if it's going up or down first. Alrighty. So we're going to do the same sort of idea with our cosine graph here, except we have a period of 4. So let's go ahead and erase that information. So period is going to be 2 pi for our cosine. So 4 is equal to 2 pi over b. So I'm going to multiply both sides by b. That will cross out. So I got 4b is equal to 2 pi. Divide both sides by 4. And so we're going to get pi over 2 when I go ahead and reduce. So I know that this is going to be cosine pi over 2. And then once again, no phase shift. So we'll just go ahead and put our x right there. But I still need to go ahead and find out, put my plus or minus in front, where my midline is and what my amplitude is. So right here, I'm going to go ahead and find my average for my midline. So 0 plus 8 divided by 2 is going to be 8/2 or 4. So we'll say plus 4. So we'll do the same trick that we did before. So my midline here is at 4. My min, as we can see here, is at 0. So how do we get there? Obviously 4. How do we go up to 8? Obviously 4. So we'll put a 4 in front. And then, ladies and gentlemen, boys and girls, that's our graph. Easy peasy lemon squeezy. All right, last one's going to be tangent. Tangent is a smidge different, but it starts out pretty much the same. So I'm going to look at my period. Now here's where it's different. So period for tangent is pi divided by b. So if this is going to be a 4 pi, it's equal to pi divided by b, multiply both sides by b, so that cancels, and we're going to get 4 pi times b is equal to pi. Divide both sides by 4 pi, and we're going to get b is going to be 1/4. Alrighty, so I now know that that's going to be 1/4, so I'll erase that. But I have a phase shift, so we'll get to that in just a second, but I'm going to go ahead and say that it starts out with tangent of 1/4, and I'm going to put my x right there, and now I'm going to worry about this phase shift. So my phase shift is a negative pi, okay? So that means that when I solve for it, I had x equals negative pi, okay? And so when I bring that over, I'm going to get x plus pi is equal to 0, and that's how it would look in our parentheses. So I'll say plus pi. And now, ladies and gentlemen, we take a look at this and go, there's no domain and range specification, so plus or minus, and we're done. Alrighty, domain and range for these functions. So ladies and gentlemen, boys and girls, you have a couple of options. You can graph them. I'm a visual person, so I'm going to graph them. If you want to try to just look at them, good luck. But I think graphing is the way to do this. You can look at it on the calculator. You can really just look at your period and make some distinctions from there. But I'm going to go ahead and start with that. So it is a tangent function. So now my period is equal to pi divided by 2. Okay. And then what I like to do is I like to say, alrighty, so my normal tangent is going to look like this because there's no phase shift, so we're good to go. Okay. Normally, it's in between this right here and this right here. This asymptote and this asymptote would be negative pi over 2 and pi over 2. Okay. But because we have a different period, okay, our period is pi over 2, I'm going to shrink that down, okay? So basically, I know that this is pi over 4 that's negative and pi over 4 that's positive, because my whole graph that's going to happen here is going to have to happen between that pi over 2, okay? You could do your gap amounts, however you want to decide that, but here we at least have our graph. We don't need this necessarily, that negative 9, but if you wanted to, I would say that this is going to be over 1, down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. And then over, again, doesn't really happen. So our range, let's look at the one that's going to be easy because my arrows are going down forever and up forever, is going to be all real numbers. And for tangent, your range is always all real numbers. What your domain is your domain is going to be a little bit more complicated because it's x cannot equal certain values. And so we always go to your first positive asymptote. So that's why we had that question earlier. So my first positive asymptote is at pi over 4. And then we say, when am I going to keep seeing that again? So we're going to keep seeing that again for our period here at pi over 2 times k, because that could be continuing on forever. And that's going to be our domain and range for that graph. All right, cosine. So again, graphing this one, especially with it being moved up 7 and have a negative 5, it just seems to me a lot easier to do that. So we're going to start here. I'm going to move up to 7. So 1, 2, 3, 4, 5, 6, 7. Boom, 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 boom. There's my midline. And then I really need to know my max values here and my min values. So I would go up 1, 2, 3, 4, 5 from there. So this right here would be my max. And that point is at 12. Because again, that's 7. So my amplitude being 5, 7 plus 5 giving me 12 kind of makes sense. And then my min down here is going to be at 2. And then because it is a cosine function, it's going to go ahead with a negative and look something like that. Cool. So my domain for sine and cosine is always from negative infinity to negative infinity, really because there's no asymptotes. Anytime there's asymptotes, you got to worry about your domain. If there's no asymptotes, it's going to be all real numbers. Unless it's a rational function and there's holes, but that's a different story. All right, range. So range in this case, these arrows continue to oscillate. It's not going to go up forever. So really I need to know your max and your min. So your min is at 2, your max is at 12, and it does hit those values. So that's your domain and range. All righty, we've got to our last one here. This is our last one that we're going to be seeing on our final reviews. Time flies when you're having fun. So this is a secant, and then secant is obviously related to cosine. So I'm going to start with, let's draw my cosine graph. So 1, 2, 3, 4, 5, 6, 7, 8. So I have a midline here at 4. So 1, 2, 3, 4. So I'm going to draw this as if it was a cosine. So that's my midline here. And then I'm going to go up 3, 1, 2, 3, down 3, 1, 2, 3, because of, oh, thank you for that lovely notification. So that's going to be my max, and this is where I'm going to start, and this is going to be my min. That's going to be helpful for graphing the cosine and for our domain in our range here shortly. So let's continue. We need to find out what our period is, so I'm going to take my 4 and go period is equal to 2 pi divided by b. So 2 pi divided by 4. So that's going to be pi over 2. So again, that means a whole rotation in the time of pi over 2. So if I look at that as far as what's going to happen, I need to divide this by 4 to find out what my gap amount is. So my gap is going to be pi over 8. So we'll put in my little tick marks here. But now I know that these tick marks are going to be, this is at pi over 8. This one will be at pi over 4. This is going to be 3 pi over 8. And then this will be pi over 2. Cool. So, ladies and gentlemen, we're going to go ahead and go, cool. So it's going to start here. Go down, boom, boom, boom. And then this is my cosine graph, right? Looks great. Well, it'd be great if it was cosine, but we are looking for secant. So I'm going to erase that graph real quick. Anytime it hits your midline, that's going to become an asymptote. So I'm going to need to know that that first asymptote is at pi over 8. That's going to be helpful. I have another asymptote here at another 3 pi over 8. And then I'm going to turn them inside out. So there we have our graph. So let's go ahead and take a look at what's going down. So our domain, we have asymptotes, so we got to worry. So our first one, remember, x cannot equal pi over 8 because that's our first one. And then we see another one here at pi over 4. So we're going to say plus pi over 4. Okay. So in the distance, the pi over 4 came from the distance between these two asymptotes. Okay. And so that's why it's not another pi over 8, is because I went 2 pieces to get there. So our range, so going down, this part looking down here, I've highlighted in green. It's going to be from negative infinity. And then right here, that min was at 1. I didn't draw it very well, but it was at 1. So it'll look like this. And then going up, which we'll do this one here in pink, that's going to be from our max. So our max here was at 7. and then going to infinity. There we go, sports fans. So, ladies and gentlemen, hopefully this is helpful. You are officially ready for your final. See you next time.